Hey everybody, welcome back. Thanks for joining us today. So, as always, I'm taking questions in the chat on YouTube and also on the forum. And, these walkthroughs, particularly on a day like today where the material is a bit of a grab bag, are a great chance for you to ask questions. This is actually a pretty small group environment, so don't be shy. I'm more than happy to, launch into any type of explanation or reinforcement that you might need. If you want to look at some of the old homework problems, that's something that we could do in this time as well going forward. So really this is your time, right? It's one of the times that you have with me during the week. We have a lot of staff for CS125 and we have a lot of opportunities for you to connect with us, but this is your daily chance to connect with me. And so I don't want to feel like I'm just kind of sitting here talking at you. If there's stuff that you want to discuss, if there are, questions you have about the material or about stuff that's related to the material, please do ask. And we'll try to make this sort of as interactive as possible. That's the benefit of, having the lesson content, already there, is the sense that I don't really feel the need to kind of regurgitate everything that is already there in the lesson. So this is really a chance to touch up, provide an overview for you, but then also touch up on some areas that might be in areas of concern or questions or whatever. So today's subject is sort of wrapping up, right? From time to time, we try to set up the material in this class with as much conceptual integrity as possible, but there's moments where it's kind of just like, there's a few little bits and pieces of stuff that we haven't swept up yet. So we got to pause and just kind of handle some of those loose ends, shall we say. And today's one of those things. So today's lesson is a little bit of a mishmash of, the little few pieces of function design that we hadn't covered, some bits about sort of looking at patterns in the code we write, and then a few other pieces of syntax that we haven't seen. And then also tracing function execution. So this is one thing, there's several walkthroughs on this already, but I would really encourage you to use system.out.println as a mechanism for starting to build up a mental model of how the code that you write executes and how the computer we refer to this as control flow, how the computer, which lines it's executing, why it enters an if statement or doesn't enter an if statement, stuff like that. The reason for this is that, we are starting you guys out on your journey in computer science, trying to build a strong foundation for you to succeed in the future. However, some of the things that we're doing right now don't necessarily work out all that well later on. So one of the things that we used to do in this class is people used to write code by hand. I thought that was a pretty terrible idea because that's never something that you do when you're actually building real programs. But it's worth pointing out that when you're actually working on a larger piece of code, you very rarely get a chance to kind of write this small little snippet like this and actually experiment with it all by itself. Sometimes I'll do this actually when I'm working on a larger programming project. Sometimes I actually use the CS125 playgrounds and some other playgrounds I've built in other places to help me kind of experiment with something. So if there's a little piece of the language syntax that I've forgotten or am a little unclear about how it's going to work, sometimes you run one of these tiny little examples just to remind yourself like, oh, how does this thing work, right? I sort of forgot and I'm trying to insert it into a bigger system or a bigger program. I need to remind myself exactly how this goes. But frequently, when you're starting to build larger pieces of code, there's actually no way to just run a few lines at a time, right? You kind of have to think about how the bigger program executes. And the reason I'm pointing this out is that it becomes a lot more difficult to figure out what a piece of code does through sort of manual inspection, like running it and seeing what happens. So this ability to execute code in your mind, to have a mental model for how the program is being executed given certain inputs, is really important going forward. A lot of times when you're working on a program or a piece of code and it's not doing what you want it to do, the process of fixing that code or debugging it comes down to kind of thinking through like, okay, something went wrong on this line. how did things get to this point, right? How did we get to this part of the program? Why is the value of this variable that I expected to be something not the thing I expected it to be, etc. And actually, we may look into this later in the class, but there's a set of techniques that people use when they're building larger programs that involve using a lot of what are called assertions, which means checking a lot that something is, that the value of a variable is what you expect it to be, right? And again, we may introduce this later on in one of the future lessons as a technique for building robust programs, probably in the context of the machine project rather than in these smaller homework examples. Anyway, all to say that being able to think through, without running the code, without putting a bunch of print statements in there, how a piece of code works is really, really important. This is also something that, interviewers will ask you to do on, when you're trying to apply for a software development position or get a job in computer science. They'll say, okay, here's this piece of code, tell me what happens if I give it this particular input. You kind of have to think through. You say, okay, they might ask questions like, is this return statement on line 4 ever reached, or what conditions would cause this return statement to be reached, or whatever, right? And they're not going to be like, okay, run the code and experiment with it. The experimentation that these playgrounds that we use enable is designed to facilitate you starting to build up that mental model, right? So when you're getting started, being able to run the code and actually see it print things and see what it does is really important. But what we're trying to do is get you to the point where you can think through code execution. So we have a couple examples of this, particularly in the context of calling a function. This is a process that is a little bit mysterious on some level, and it causes the code to kind of jump around a little bit in ways that we hadn't seen before. So up until now, we've looked at using a conditional statement to cause the code to not execute a particular part of the program, or using a loop to cause it to repeat something multiple times, but we actually hadn't looked at as much. We're getting comfortable with this new idea of functions, which we introduced last week, but seeing what happens when we actually call a function, right? What does that mean? And so in this walkthrough, we sort of go through carefully both an example of calling one function and how that works, and then a second example where a function calls another function, right? And on some level, if you can understand both of these examples and be able to work your mind through the process that happens when the code is executed, you can kind of generalize to anything, right? You can kind of say, okay, well, what if my function calls a function that calls another function that calls another function? I can still think through exactly what's happening. The most simplest way to think about it is whenever you see a function call as part of your program, right? So in this piece of code, we see two method calls or function calls. Sometimes they refer to it as a method invocation. I kind of like that term, right? We usually refer to it as calling a method. It's kind of like you pick up the phone and be like, okay, completely even. I've got some data for you. I need you to figure out whether or not everything in here is even or right. That's like calling. But invoking is like almost as if it's a spell, right? It's like I'm abracadabra, I invoke this function, right? It has, for me, more meaning that's tied up in language, right? It's like a password or a phrase that you enter that causes a door to open or something like that, right? So when we call this function or invoke this method, what happens is that the program starts executing that method and doesn't stop until the method completes, until I reach a return statement. Or in the case of what we'll see later, a void method, if the execution just reaches the end of the function. In a function that returns a value, every path through the function must eventually end at a return statement. So for example, if I comment out this return statement on line 11 and try to run this code, you're going to see Java's going to complain because it sees that there's a way for the code to flow through completely even. There's a way for completely even to be executed so that it doesn't return a Boolean value, and it has to return a Boolean value. It's declared as returning a Boolean value. So I really do need this return statement. I also need it for correctness, because this is part of what makes this function work properly and do the thing that I've declared it to do. But anyway, so when I see a method call, Java will stop, execute the method until it yields a result, and then replace the method call with the result, right? So if you look at line 13, what happens when I execute line 13? Well, I see two method calls actually, because the walkthrough kind of points out what you might have noticed already, which is that system.out.println is a function. It's a function that we've been calling. The thing that the function does, and it kind of has a weird name for this, although println, the end part of it makes a little bit of sense. In Python and in some other programming languages, this function has a nicer name like print that is a little bit more shorter and a little bit more clear. But anyway, in our code, we use system.out.println because that's how you do it in Java. But this itself is a function, and the reason we use this function is to tell Java that we want to display some output. In this case, to the terminal down here where we'll be able to see it. So Java starts executing this function, but then it looks at the arguments. I'm passing an argument to this function. That's what happens inside these parentheses. We've been calling system.out.println without really thinking about it, but what we do every time we use that is we're invoking a method, and what we need to pass to it inside the parentheses is what we want to be printed. And we'll talk a little bit more about exactly what gets passed to system.out.println later in the class. But for now, you can think that I can pass kind of pretty much anything I want to system.out.println, and it will try to display it for me in a way that makes sense. It doesn't always try very hard, but it does print something. So in this case, I start executing this method, but then I look and I see that the argument is itself the result of calling another function. So before I can even start printing something, I need to actually figure out what I'm going to print, and that requires executing this second function that I've declared in my code, which is called completely even. You might also wonder, like, where is system.out.println declared? So this is a function that's built into Java. It's always available for you in your Java programs. There are certain types of functions that are sort of built into Java. The most important one that we'll be using is system.out.println, but there's a few others that we'll see come up later on. But this one, you don't see a declaration for this function anywhere. And also the dot notation that we use in here is a little bit weird. And again, this is stuff that will make sense a little bit more later. So before I can start printing, wherever that code is defined, I need to figure out what to print. And so Java starts executing this completely even function, and now you'll see I jump into, when I call a method, what happens is I start executing the block of code that the method declared with the values that were declared in the parameters set to whatever the caller passed. So this is the chance for the caller to provide the method with the information that it needs to run. So in this case, the method says, in order for me to run, you need to pass me an array of int values, which I do. I declare here, and then down here I have int values, which has 3 values in it. And so when I start executing this code, values is set to an array that contains the integers 1, 2, and 5 in that order. And then I just start executing the code as if normal until I reach a return statement, at which point the function execution stops, and then I yield a result. So once completely even returns, you can almost imagine that this whole chunk of code in the mind of Java is replaced by either true or false, depending on the result of the call. Because it returns a Boolean, I know that it can only become either true or false because of the only 2 Boolean values. If this returned an int, it could become a lot of different values, but Booleans are, have a smaller number of possible values. So, this becomes either true or false depending on the array that I pass and the values that are in there. And then at that point, that println function can execute. Now it knows what its arguments are. Until then, it didn't know what its arguments are. It had to evaluate completely even. Once I've invoked completely even and it's yielded a result, either true or false, because it returns a Boolean, now I can print that to the display. Okay, so, and again, this is something that I would just encourage you to practice with, right? Take the time, think through stuff, right? So one thing that I encourage students to do, and will continue to encourage you to do, is think about what's going to happen before you run the code. First, look at the code, walk it through it in your mind and think about, okay, what's going to happen here when I call this with the values 1, 2, and 5? Now, try not to take shortcuts, right? It's easy to say, okay, well, the name of this function is completely even and it takes an array, and so it's probably going to return true if the array is entirely even values and false otherwise. This type of inference is actually really important once you start to work with larger code bases. A lot of times, you don't actually see the code for the methods or the functions that you call because somebody else wrote it and you're just using it. And so at that point, you start to rely on things like documentation, which we'll talk about more later, and the name of a method. So the fact that this method is called completely even, if you guessed that what it does is returns true if the array is all even values and false otherwise, that was good, right? And that's one of the reasons why we gave it the name completely even. If we named it foo, it would still work, but it would be harder to tell what it did. It would be like, okay, well, I'm gonna foo something. I don't know what that means. And so giving your methods descriptive names allows you to infer what they're going to do, right? The worst thing to do, I guess, would be to say, give this a name that is actually not what it does, right? Or we could call this completely odd, and then it would be very confusing to someone who's trying to use this because they're like, wait, hold on. I gave you all even values and return true, So you don't name things. Now, this could mean that I was trying to write a method that returned true if it was completely odd, and I made a mistake. That's different, right? But given that I'm trying to write a method that returns if the array is completely even is a good name for it. But when you're learning how to trace method execution, you actually want to look at the code and go through it line by line and think through in your mind how it works. Not just what it does, if you can guess that from the name, but how it does that. So again, you give it this input, you think, okay, well, first time through the loop, what's I? I is 0. What's values I? Well, that's the first item in the array, which is 1. What's values I modulo 2? So 1 modulo 2, 1 remainder 2. What's the remainder when I divide 1 by 2 as a whole number is 1. Is 1 not equal to 0? It is, and so I'm going to return false. And so in this case, I only execute the first step in the loop because I reach a return statement. We talk a little bit more in the next section where we go through common algorithm patterns about this particular type of algorithm and some of the characteristics of it, because this is an approach to writing certain types of algorithms that we're going to see over and over again. But that's an example of working this through. And you could do the second input. You could say, okay, same thing. First value of values is 0. Is 0 mod 2 not equal to 0? No, it is equal to 0, right? And so I don't hit this. I go to the next value. Same thing with 2. What's 2 remainder 2? That's also 0. I don't enter the if statement. What's 4 remainder 2? That's also 0. I don't enter the if statement. And I'm done. I get down to the bottom. I return true. One of the things that's going to help you with this process of thinking through how code works is identifying these sort of patterns or structures. So for example, whenever you see this, I'm going through an entire array from start to finish, right? I see I is 0, I see I values.length, I see I++. Okay, I know what's happening here, right? And we'll see in a few minutes a little bit easier way to write this loop, but you know what this loop does, right? It goes through every value in the array. And then when you see values I, you know what that is. That's the current element that we're looking at. So at that point, once you've gotten more familiar with some of the common idioms that we use when we program in Java or other languages, you start to think on slightly higher level, right? Instead of thinking, oh, okay, what's values I? You think, okay, what's the current value because I see values I? And then you start to think, okay, this is going through every element in the array, and it's examining each one, and it's testing to see, and when you see this, you'll see, okay, well, this is a test to see if it's not even. So again, you start to, as you start to read more code and work with more code, to see the higher level constructs, not just remainder 2, but this is basically is even, right? Not just for I is equal to 0, I++, this is going through an array, right? Every element in an array if values is an array. Okay, so I've babbled enough about this. Like I said, questions, please ask them in the chat or on the forum. I'm feeling like I'm talking a lot today, but I would love to address any questions you guys might have. All right, so the next part of today's lesson is on patterns, and this is something that I just want to identify early on, and then a topic that we'll come back to as we continue to write more code together and explore computer science and lots of other topics this semester, which is this idea of observing patterns, right? Identifying patterns, being able to start to see these as building blocks. So, when you guys start working on slightly longer pieces of code, you may feel intimidated at first. That's pretty normal, right? You say, oh, I've never written a program that's more than 10 or 20 lines because I've just been doing these small homework problems. How are you expecting me to write like 100 lines? And the way that you do this frequently is, if you look at that 100-line method, it's not really one thing. It's kind of 3 or 4 higher level steps that you're composing together. So you almost think about kind of like starting with these building blocks. So our first building blocks were things like, setting up a variable, conditional statement, a loop. Now we're starting to combine those into slightly larger building blocks, right? And then eventually we'll take those larger building blocks and start to combine them into even bigger things. And that's when it really gets fun, right? Because then you can actually like build an Android app, right? By just composing together different pieces of stuff that you already know how to do. So again, frequently when people work on a longer piece of code, they think, okay, what are the things I need to do top to bottom? And then they write like a little chunk of code that might look a little bit like what we have in one of these playground examples to accomplish that step, and then they move on and they do the next thing and then move on to the next thing. And when they're done, even though they've written like a function that may look long to you, it's broken down into a series of steps where the results from the previous step are being used in the next step, and each one is probably something that you'd be able to recognize. So let's look at a couple of these patterns that have already emerged. I want to present 2 different, and for the sake of this kind of walkthrough together, we'll look at them kind of side by side, right? It'll be a little more fun. So these are 2 loop patterns. Both of these are patterns for working with data in arrays. Both of them use a loop, and both of them are quite useful. They yield a result, but they're different, right? So let's look at them. Let's look at this one first, okay? So both of these are methods. One returns a Boolean, the other returns an int, but that's not important, right? Both of them take a single argument, which is an array, in this case of integer values, and both of them essentially do a computation over the array. This one, and again, please watch the walkthrough because this is just kind of a silly example. You may look at this and be like, why are you computing the length of an array using a loop? Just do values.length. It's very simple, right? You told us that last week. So anyway, but the reason I'm doing it this way is because then we'll build on top of it, we'll do some cooler stuff, right? But here's so both of these, I'm going to point out the similarities first. Both of these have a loop that goes through, that is declared to go through the entire array, okay? So if you look, these 2 loop declarations are identical. Both of them at least set out to go through the entire array. Now, that's sort of the similarities. Now let's look at the differences, okay? So in this first example, I have a variable that I declare outside of the loop. And then you'll see that there are no breaks or returns in the loop. So this loop is always going to go through the entire array. It's never going to skip some elements. It will always look at every element in the array. And then it's also using every element to adjust some value. And then when it's done, it returns that value. Now, again, the stupid example I'm using is, imagine that I wanted to count the number of elements in an array, and I was kind of dumb because I'm already using values.length here, so I clearly know that this exists. But I could do it this way. This is not a good example of how to count the number of elements in an array. Just use values.length, okay? Again, I want to emphasize that. I'm always nervous when I show people bad code because I'm like, oh gosh, what if they end up thinking that this is the right way to do things? So it's not, right? I should have put a big comment here, like, do not compute array length this way. But what's cool about this is that there's so many different ways to modify this template to accomplish different things. So, for example, let's say that we wanted to compute the sum. right? Instead of, and this is one of the examples I use in the walkthrough, so I'll kind of ruin it for you, right? So I'm going to rename my variable to sum. And now the thing I do differently is instead of adding 1, because that doesn't work, that doesn't produce a sum, that's just going to produce a count, but I add values I. So now, with only a few small changes, most of which were to the name of that variable to make the function make more sense. I should also rename the function itself, right? So this could be array sum. I've converted from length to sum, okay? Just using a small change. The other way that you modify this, I'll just go back to the original template, is you put conditional statements inside the loop. So let's say so you can probably see how to build on top of this to do things like, count the number of values that are odd, count the number of values that are negative, sum all the values that are positive, compute the average, right? I mean, the average is just a sum followed by an operation on that sum. I can compute, there's a variety of different statistical pieces of statistical information that I can compute using this. I can find, the minimum and the maximum. That's slightly different than this, and it's sort of a slightly different pattern, but it's not too different. But there's actually quite a few different variants of this that I can use in certain situations. So the key ideas here are, I have a variable declared outside the loop. Inside the loop, I modify that variable in some way. Usually, if I'm counting, usually I'm going to increment it. If I'm doing some other type of statistic like a sum, I may modify it in a different way. And then usually I have some type of conditional statement inside my loop that's sort of only selecting some elements to be included. So again, if I want to count negative values, I check to see if the value is actually negative before I increment my count. So that's our first pattern. So let's look at the second pattern. I'll keep them both on the screen because I think it's nice to see them side by side. Okay. Second pattern is distinguished. So one thing you'll see is that there's no variable outside the loop in this example, and there is a return statement inside the loop. So what's different, the first thing that we can notice that's different here is that this function may not reach the end of the array. Because there's a return statement in here under a conditional expression, as soon as I find a value that causes this conditional statement to become true, I'm going to return immediately, and that's going to be it. I'm not going to reach the end of the array. So you might think of this is sometimes I think sort of referred to as an accumulator pattern. I have a variable outside the loop, and I'm accumulating information in it as I go through the loop. This I'll call kind of more of a search pattern. In this case, I'm looking for something in the array. I'm looking for a value that has a particular property. And as soon as I find that value, I can make a decision about what the result of the array should be. What the result of the function should be. And that's why I return true. So in this case, I'm searching for something, right? I'm looking for a particular value, in this case 4. This is kind of a dumb example of a search function because it's very easy to make a more general search. But in this case, I'm looking for a particular value. As soon as I find it, I don't have to continue the rest of the loop. I can just stop there, and I'm done. There's also normally, in fact, it's kind of required, you need a return statement outside the base of the loop at the bottom. So the idea is if I find something in the loop, that allows me to make one decision. If I don't find something in the loop, then I return the other result. And in the walkthrough, I go through examples both where I return false in the loop and true outside the loop, and as in this one, where I return true inside the loop and false outside the loop. And this sort of comes down to what I'm looking for and whether or not the thing that I'm looking for causes the result to be true or false. So sometimes I'm looking for a contradiction. So for example, if I'm trying to test if all the values in the array are even or odd, then as soon as if I'm testing for evenness, as soon as I find an odd value, I know that not all the elements are even, and I return false inside the loop. If I get through the entire loop and I haven't found an odd element, then I can conclude that all the elements are even, so I return true outside the loop. When I'm searching for something like this, typically I return true inside the loop and I return false outside the loop. As soon as I find an element that has some property, in this case the element is equal to 4, I return. Otherwise, if I go through the entire loop and I've never found an element that has that property, then I conclude that the array doesn't contain that element and I return false. Okay, so again, these templates are just designed to be building blocks for you that you can return to and might find useful in some of the programs that you write in the future. So just something to keep in mind. All right, last couple of topics. I'm just going to go through these quickly and try to open the floor for questions in a minute. Last couple topics here. So there's a short bit on method overloading here. I'm not going to go too much into that because it's just not something that we use a lot in this class, particularly not early on. Today's homework problem is on it, but I think it's fairly straightforward. The idea is that in Java, two methods can share the same name as long as the method's signature is different. And I'll let you explore the walkthrough to figure out what I mean by method signature. All right, last two new topics. So void methods. Usually when we call a method, what we want, or a function, we want it to do some work for us. We want it to yield or return a value, right? The idea is that I'm taking some logic, maybe an algorithm that I've been using in several parts of my code, and I'm putting it in one place so that all those different parts of the code that need to perform that task or perform that computation or run that algorithm can use the same code. So usually what happens is I provide some inputs and then I expect it to return a result. There are some cases in which a method runs but then doesn't return a result. And so in those cases, Java provides a special void keyword that I'm using here that I can use to indicate that the method does not return a result. However, void methods can still use the return statement. And in this next walkthrough, I will show you how that happens. Okay. Last new bit of things, so I'm going to go through this, and I'm going to take a quick break and come back in a few minutes. Hopefully by that point, there will be some questions queued up. So the last thing here is to look at this new structure called an enhanced for loop that is particularly useful for working with data in Java arrays. And so the way that we get here is we go back and we do a little bit of review of older loops that we used. So the first loop that we introduced you to was this while loop, right? And then we said, okay, well, there's this really common pattern in a while loop where I use it in a particular way in my program to go through an array in particular, and I can actually make a more condensed version of that using this new array called a for loop. Well, it turns out that this loop, where I have an array of values that I'm going through one by one, is so common that Java has yet another piece of specialized loop syntax that is specifically designed for working through each element in an array. And the walkthrough that's here will help you with that. Okay, I'm going to step away for 2 minutes. Please post some questions for me. Like I said, happy to answer questions about today's lesson. Happy to go through some of the old homework problems that you might be curious about the solutions for. Anything is fair game. I'll be back in just a second. All right, I'm back. Let me see if I've got any questions. Reverse print assignment. I will do that one. I take requests. All right, so let's look at reverse print. That's over here. Okay. So let's talk through how to do this. This is a great question. When you work on assignments for this class, I would say the number one thing to keep in mind is reading the instructions. You know, that's a big part of being a computer scientist, is learning how to translate from English into code. The descriptions for the problems are written in human language, right? You know, we don't say, here's the declaration of the function that you're supposed to write. We don't always even tell you what the return type should be. We expect you to kind of look through the description and figure that out, okay? So let's do that together. Let's read the problem. So declare and implement a function called reverse print. You should accept a single array of char values as your only argument and print that array backwards, one character on each line. Your function should return the length of the array as an int. So let's think about our method declaration and the 4 parts to it. So left to right, I need a return type. Let's try to figure out where I saw that. So I should return the length of the array as an int, okay? So my return type's right here, okay? I'll put that down here first. Int. Now the name, right? Declare and implement a function called reverse print. Okay, so I've got a name here, and I'm just going to cut and paste that name because I'm lazy. Okay. What about the arguments for the method? What are the arguments that it should accept? It says you should accept a single array of char values as your only argument. Okay, and print that array backwards. But first I'm focused on this. You should accept a single array of char values as your only argument. So I know that my arguments go in here, right? Then I'll just put a placeholder for the body of the loop. A single array of char values. So I'm gonna, that's the declaration for an array of char values. And now this is actually a part that's never in the description of the function, because this is up to you to decide. You can choose to call this whatever you want. It's up to you. We've been using values a lot for an array, so let's just continue to use this. When you're getting started, I would encourage you, use the grader to help you. One of the things the grader can do is help make sure that you've got the function declaration designed properly. And so what I'm going to do here is your function should return the length of the array as an int. I'm going to put in that part because I'm pretty sure I can figure out how to do that. But I'm actually not going to worry about the reverse printing yet. So let's say return values.length. And now let's test this. Okay? And so you'll see that it's not right. That's okay. But that'll help catch errors like this. So what if I did this, right? Now you'll see that I get a design error, right? And it says you didn't provide method reverse print, right? And the reason is you spelled it wrong, right? That'll also catch errors like, let's say, like this, right? Same problem, right? So if you run this, it says didn't provide method int reverse print, you know, array of characters because I'm returning a double. If I put my int back here, let's say I only took a single char value. Well, now values.length is not going to work. So let's say return 0. I'm going to get the same error message again. So, you know, once you have, particularly over the next few weeks when we're writing a lot of methods, once you feel like you have the method declaration set up properly, I would encourage you to just run the autograder on it, even if it doesn't do anything yet. You have to return something, otherwise we can't compile your code. But you know, you could return just the dummy value, in this case like 0. But this helps make sure that you have the declaration set up properly. Okay, so now we're going to go back to here. This is the one that I actually got some bad, I need to spell things right, got some bad values on. Okay, so now I can see that I'm not doing the right thing. And of course I'm not, because I haven't tried to solve the problem yet. All right, so what I need to do is I need to go through a loop backwards. And there's two ways to do this. One way is to go back and look at some of the the previous lessons on loops. So let me see if I can open this in a new. Let me open up a new tab because I don't want to browse away from that and lose what I was working on. So here's my loops lesson. And in this lesson, when we did the for loop, right, we talked about a bunch of different ways of going through different loops. And if you spend some time exploring this section, you probably so here's an example of a loop that goes down, right? This loop starts at 16, works its way down. If I change this to down by 1, you'll see that now I see something that looks a little bit more like what I might want, because I'm trying to go through this array backwards. There's actually two ways to go through the array backwards. We'll do both. But one way, and the way that might seem a little more obvious, is to design your loop so that your loop goes through the indices of the array backwards. So rather than a lot of our loops where we start at 0 and go up to the end of the array, we actually want to start at the last index of the array and work our way down. Then what we put inside the loop will be pretty straightforward. So let's try doing this. And when you're when you're getting started, particularly when you're designing pieces of code like this, it's good to start with little chunks. Try to figure out what works. You can use our playgrounds to mess around. You can also print stuff as part of your submission that will be shown to you, even if it's incorrect. And that can give you a sense of what's going on. So let's try to get this backwards loop to work first. That's going to be the first task, really. Once we have that working, the print part will be the next thing that we'll tackle. All right, so I'm going to say write a loop that goes through values backwards. That's our goal here. I'm going to use a for loop, and going back here and kind of looking at how this was set up. Okay, I'm going to try I is values.length. I is greater than or equal to 0. Let's try I is greater than 0. I minus minus, right? And then instead of worrying about finishing, I'm just going to print I here to see what happens. Because if my code runs, this will at least give me a sense of, am I going through the right indices? The first thing I need to do is write a loop that goes through the values backwards. If I can't do that, then I can't finish the problem because I'm never going to be able to print things. So let's try running this and see what happens. Okay, so now what I see is that my submission printed 2, 1. It looks like the array had length 2, right? So when we test your code, this whole system was designed for this class. I just want to point that out. So if you guys have feedback about how to make it better, please do let us know. But we do try to give you lots of information about what we did and what went wrong. So in this case, what we did is what we're telling you is we said, we tested your code. We passed this as the value for values. We passed an array with first value A, second value to the character 0. And we expected you to print 0 first and then A because you're printing the characters backwards. You printed 2 and then 1. Now in this case, we're just experimenting, so this is okay, but we're going to look at our output. And now we're going to tell ourselves, are these the right indices for a 2-element array? So if I have an array with 2 elements, what are the valid indices for it? Well, remember that we started 0. So the first valid index for that array is 0. The second valid index is 1. My submission printed 2 and then 1. So I've got what sometimes we refer to in computer science as an off by 1 error. I have a mistake, right? And so let's go back to our loop and try to figure out why this happened, right? So the problem is values.length is 2. And that's how I initialize my loop index variable. 2 is not a valid index for an array of length 2. And again, that's tough for people to understand at first. But for an array of length n, the last valid index is n minus 1. So if my array has length 8, the last valid index is 7. If my array has length 632, last valid index is 631. So in this case, given the example that we used to test the code, the array length was 2. So the first valid index is 1. Okay, so I need to start. I'm trying to start at the last element. Okay, so I need to start my index variable 1 element smaller. All right, so let's try this. Let's run that. Okay, so now I see that I have a different problem. which is that I only see the value 1 printed. I never see 0. So why didn't I print the array index 0? Well, let's look at how my loop works. So I set I to 1. Value's not like this 2. 2 minus 1 is 1. So I get through the loop the first time. Then I decrement it. So that's good. I did the right thing. I'm going backwards. I want to go backwards through the indices. But now I'm comparing if it's greater than 0. So now it's 0. And 0 is not greater than itself. Strictly greater than. And so this check fails. I drop out of the loop. So now, but the first time I was starting one element too far, now I'm ending one element too early. And so what I need to do is fix this so that it looks like this. And what we've arrived at, this particular line, this, so there's a pattern to going through a loop forwards. For I is equal to 0, I is less than values.length, I plus plus. There's a pattern for going through an array backwards. We don't use it as often, but this is it. I is values.length minus 1. I is greater than or equal to 0, I minus minus. This will go backwards in reverse order through any array. Okay, so let's run this now. And now you'll see that the solution is still not correct because we're not actually trying to print what's in the array yet. But I do see the right indices. And again, when you're just getting started, building up the skeleton of your solution like this, make sure you get one thing to work before you try to get the next thing to work. The reason I suggest this is because when you have 2 or 3 problems with your code that are all kind of counteracting each other, it gets very hard to figure out how to proceed. The best way to proceed is to try to have one problem at a time, right? Just isolate things, get that one next thing to work. So now we're sitting pretty. We have a loop that goes through the array backwards, which is what we wanted. So that's pretty good. So I'm going to take this out. Now it says to print that array backwards, 1 character on each line. So now what I need to do is I need to say print the current character on its own line. So how do I get the current character in the array? Well, I is the indice of the character that I want to print, and so the current character is going to be values I. The reason why we said this about its own line is that there's another way to print things in Java using system.out.print. The difference here is that when you call system.out.print, it doesn't advance to the next line. It puts everything on one line. So for example, if I do this, you'll see, and in this case what happened is you didn't print a new line, and so we didn't think that your submission produced any output. But if I use my familiar print lin, which puts some things on its own line, now what you're going to see is I'm done. So that is the approach to this particular problem. So let's kind of go back and talk about sort of just how we process this, right? So read the problem description, right? When we ask you to write a function, work on the function's signature first and run that through the grader a couple times until it seems to be happy that you've at least set up your function properly. The reason that I suggest this is because I've seen so many cases in the past, and our error messages are better now, right, than they used to be in the past. So in the past, a lot of people would do things like this, or they would forget to capitalize, and they would get this weird message from our autograder and they couldn't fix it. And I can't tell you the number of times, and I always felt so sorry for people where they would get something wrong on a quiz and they'd be really upset, and they would come to my office and they would show me the code, and I would be like, because my eyes have been trained to see this stuff, right? I can see missing semicolons from like 20 paces, right? So, and I would be like, and that would, yeah, and they usually didn't like that very much. But that is something about computer science, right? Like one single character makes a huge difference, right? I'm missing semicolon, I'm missing bracket, I'm missing brace. To you, it may look the same. To the computer, it's a totally different thing. So trying to make sure that you follow the instructions. So step 1, get that method signature nailed down. Step 2, go through, and I should have done this using several different comments, but figure out the different building blocks of the solution that you need. So in this case, I was told to go through the element backwards, the array backwards. So I know how to go through the arrays forwards. I know how to use a loop to do that. I need to make some adjustments to my loop so that I go the other direction. And then you do that. You just kind of fill in the missing parts, right? at each step, trying to figure out how to test your code to make sure that it's doing the right thing. Is there a way to print some output, like we did with the indices, right? So, what you saw there are several common mistakes. I mean, I'm gonna be real with y'all. I mean, I don't write reverse for loops all day. I've definitely made the mistake of starting a reverse for loop at values.length, and problems ensue, right? But when you're getting started, the way you catch those is by kind of trying to examine things along the way, right? Don't try to solve the whole problem at once. In our case, it was just like, let's just figure out how to set up the reverse for loop first to make sure that's working properly. And until we're satisfied that it's working properly, we won't try to finish anything else. And then you kind of do that one step at a time, ratchet forward. All right, so there was a question about the enhanced for loop. Yeah, let's do that. So let me get back to here. Let's do an enhanced for loop. So, the idea here is that, and I'm just grabbing a random playground here, right? Let me set up an array of values. So, we saw how to go through an array using a while loop. My goal here is to print every element of the array in forward order on its own line, right? So we just did reverse. So now we're going to do forward, and I have to remember to increment things. So here's how to do it with a while loop. And we noticed that this was kind of annoying. I have this variable outside the loop. I have to remember to increment it down here. What if so we came up with this different form of a loop that really emerged out of this common while loop pattern. So now I'm going to move all of this into one place. So I don't need the variable outside my loop, and I can remove this I++, and I have a piece of code. It's mad at me about something. Let's see here. Oh, I need to actually declare a variable. See, I'm just claiming how great my eyes were, and then they failed me. Anyway, so now we've moved kind of all the parts of that previous thing into one line. Yeah, but this is still kind of a lot of typing for a very, very common operation, which is going through an array in forward order. So Java provides us with another option, which is this enhanced for loop. So here's what it looks like. And I'm going to print value. There we go. Same thing. So let's look at the differences here and get a sense for what's going on. One thing to notice is that in the enhanced for loop, there is no index. So this is only useful in cases where I don't care where in the loop I am. Now, in today's lesson, we go through several of examples like searching an array, summing an array, counting an array, where I don't care where in the array I am, right? I'm only using that array index variable to get me the current value at that position. So I don't care about I. There are problems where you do care about I, and we'll look at some of those over the next days, next week or so, right? There are some more complicated examples of doing things, like let's say I'm looking for two elements that are side by side in an array. Well, at that point, I need to know I because I'm going to look at either the next element or the previous element in the array, using I to grab that, help get that for me. Again, we'll show you how to do this soon. But for a lot of the cases where I'm just going element by element through the array, what I care about is having a loop that takes me to every element. And if I don't need the index, the enhanced for loop will do that. So the right side of this is an array. It's actually a little more general than that, but I don't want to get too far ahead of ourselves. What I put on the right side of an enhanced for loop is actually anything that can yield values one at a time. The left side is the thing that kind of receives each value at every step in the loop. And this has to be a type that is the type of the component or the elements inside the array. So if I have an array of ints, a single dimensional array of ints, we'll talk about multi-dimensional arrays soon. For now, I have a single dimensional array of ints. Each element in the array is an int. And so the enhanced for loop, what it does is it pulls items from values one at a time and assigns them to this variable that's in the declaration value, which I have available to me inside the loop. And every iteration through the loop, value receives the next element in the array. And so again, you can see sort of the progression from the while loop, where there was a lot of syntax, to the for loop, where at least I brought everything up into one place, but I didn't really lose any of the syntax. It was just a little bit more organized because I had everything I needed to understand the loop looking at me right away when I looked at the for loop declaration. Now the enhanced for loop takes it even a step further, where it says, you know what? If you don't need the index, don't bother with an index, and you can use this syntax. Now again, if you need the index for something, you can't use an enhanced for loop. But if you don't need the index, this can be a good option. All right, let me see if any last minute questions. No, I don't think so. We're good. All right, so thanks everybody for showing up today. I hope this was helpful. Same time tomorrow. Enjoy today's lesson.